Hey everybody, welcome back. In this video, we want to solve problem 1423 on LeetCode. So in this problem, we are given an array of integer called card points, which represent a point for a set of cards. And we are also given another integer k. We want to take out or select k cards from this set of cards, and the task is to maximize the point that we can obtain by taking k cards from this. But there's another rule that we can either remove cards from the left or from the right at each step. In the first example, as you can see here, if we choose the three rightmost cards from this set, the sum of them would be 12, which is the maximum case without taking anything from the right. Or in this other example, in the second one, we want to take two cards. So it doesn't matter, since all of them are equal, we can either choose one from the left and the other one from the right, or choose the left two or right two. And finally, in the last example, as you can see, we want to select k cards, and the length of them is equal to the, so we have 7 cards, so if we take all of them, it would be equal to the maximum value, and the card points are always positive. So the other way of looking at this problem, let's say we have an array of n cards, so the length of card point is n, and we want to find out at some point, let's say we have taken, if we add up this left and right together, it would be the length of them would be equal to k. So we can either look at this problem by maximizing the sum of this left portion and right portion in terms of points, or whenever we select any k cards from either from the left or from the right, so we are left with n minus k cards in the middle. So this problem is equivalent to looking at this problem by minimizing or finding a subarray of size n minus k, and the task is to minimize the sum of this subarray, and that means that anything left on the left or on the right is maximized, since this is the minimum subarray of size k that we have found. So let's say the lengths of cards are n, so then card points. The length that we're looking for to minimize is n minus k, right? So n minus k. So for a given index, let's say for I, we can either iterate starting from the first one and then iterate through at the end, and in a second for loop, so we can add up I to I plus k for a given index, or I plus length, sorry, and then add up and find whichever is minimized as the answer for this problem. But is there a way that we can quickly in O1, without necessarily iterate through lengths or the subarray and add them up? Is there a way that in O1 we can say what is the sum of that subarray from I to I plus lengths? And the answer is yes. So we can store a running sum for a given array. So starting from 0, whenever we see a new card, we just add it to that. So in this case, we see 1. And then for the next card, we simply add that to the last value in that subarray. So it's 2, so the sum would be 3. And then 3 would be 6, and so on. So this array or running sum represents, for a given index I, is the sum of all elements from the first element to that index. And simply, whenever we want to find out the sum of the subarrays from index I to j, by just looking at the indices in this array, so we know that index I represents sum of all values from 0 to I, and j similarly represent the sum of values all from 0 to j. So if we subtract these two, you're removing this first part, and it is in O1 we can quickly find the sum of all values from I to j. So let's build that first. So I call it running sum R sum. Initially it is 0 without we haven't visited any card yet, and for card in or for point in card points, we are adding what is the new value. So the last element in the running sum represent the all sum that we have obtained plus the new point, and we want to add that to our array. So we can say our sum that append this new value, and that's it. So what is the last value in this array? So the last one represent, as we discussed, each index represent the sum of all values from 0 to that index. And simply the last one represent the sum of all values in the array. So in this example, for example, if we calculate the R sum, the last value would be 55, representing the sum of all values in that. So total is R sum minus 1. So this is the sum of all values. And as we discussed, we want to find the sub-array of size length and find the minimum of that. So what is that? So now we are iterating in the card points, which is for I in range starting from 0, and then what is the last one? So n minus length plus 1, because we have added some initially as a path to our R sum. So instead of n, now we have n minus 1. So I can say n plus 1 minus length. This is more clear. We are iterating through that, and in O1 we want to find the sum of the values from some index to I plus length, which is the array that we want to minimize. So it would be R sum I plus length minus R sum I. So this is the sub array. This the sum of the values in that sub array that we want to minimize. So we want to say the minimum value in this portion. So we are iterating through all sub arrays in O1. We can find out the sum of the values, and this for loop is in On. So this is the minimum sub array. And what is the answer for this problem? As we discussed initially, if you find a sub array that has some value, we also store the sum of all values in the points for the whole cards in this set of cards in total, and we also find the minimum value for that subarray. So if we subtract these two, it is the answer for this problem, representing the sum of the values that we have not chosen, or anything left on the right or left in this subarray. So we can say total minus. So this would be the answer. And for simplicity, since we don't need total here, I can say R sum minus 1. And just like that. And that's it. So if I submit that, there we go. And that was everything for this problem. We have used running sum. And so we calculate this portion in On. Also, since we are iterating in maximum of n, if length is large, so it would be smaller, but on average cases, we are finding out in this portion as well in On. So the total time complexity of our problem is On. Also, in terms of space complexity, since we are initializing a new array of size n in our code, the memory complexity of this solution is also On. So that was everything for this problem. Hope you enjoyed it.